Cool. So, like I said, we split them up into two terms, and I know that 4 goes to the front. 1 over x to the 5 is x to the negative 5, and that's easy to differentiate. Cubic root of x is x to the power of 1 over 3. Yeah, so 1 over n plus 1 to the power of n plus 1. Yeah, so that is the easy thing. Now, this one here needs a little bit of rearrangement, yes? So solve dv by dt. What do I need to? I've got the variable is t, so this expression to the right needs to end in dt. And I've got dv, so if I take integral of dv and then integral of 8t plus sine t dt, yeah, integral of dv is v and plus c. 8t, easy to integrate. Sine of t is negative cos of t plus c. Okay, and then it says where v of pi over 2 is equal to negative 4. So when v is negative 4, t is pi over 2. Yeah, and we just substitute those values. So v equals negative 4 and t equals pi over 2. Put them in here. Yeah, to find what? The constant of integration. And I've got c equals to blah blah. And then the expression of vt is going to be 4t squared minus cos t minus 4 minus pi squared. Okay, and that again is worth an u. The diagram below shows the graph of y equals 2 plus k e to the power of minus x. The shaded area is bounded by the above graph x equals 0, x equals 4, and the x-axis. So x equals 0, yeah, x equals 4, the graph, and the x-axis. All right, find the value of k if the shaded area is 11. So what do I need to do here? In principle, someone help me. I've got the integral between what? 0 and 4 of 2 plus k to the power of minus x. Yeah, integral between 0 and 4 dx. Yeah. So like I said, and that, I know that that area is equal to 11. If I integrate that, I've got integral of 2 is 2x. Integral of k to the power of k e to the power of negative x is what? K stays k. E to the power of minus ex is a e to the power of negative x. And negative x differentiated is negative 1. So that's why I've got this negative here. All right, all good? From 0 to 4, and all that is equal to 11. Yeah, up to here, you do this stuff up to here, you get a u. Now, you isolate the, you expand this, so from 4 to 0, yeah, when x is 4, 2 times 4 is 8, k e to the power of negative 4. When x is 0, I've got 0 here, and I've got e to the minus 0 is 1, and the k, yeah? All that is equal to 11. I isolate the k, put it in as common factor. So from here on is just what? Algebra. I don't know why they give this jump from u to r for finding k, because this is just algebra. There is no integration, no calculus involved here. All right, you just need to rearrange and find the k, then enter. If you end up with this, yeah, so this is not a literary result, this is a numeric result. 3 over 1 minus e to the minus 4. Why is that? Why is it numerical and not literary? Because e is a number, is a constant. All right. So if you end up with this result, don't work it out as 3.056. That's fine with me. I'll give you the R. Wonderful. Shut up. A curve passes through this point, 1 and 2, and 1 over 4 and negative, and has a gradient which is inversely proportional to x squared. Find the equation of the curve. So I know that the gradient is inversely proportional to x squared. That means inversely proportional is 1 over x squared times k, whatever k may be. Yeah, but that is the gradient. All right. So now I rearrange that a little bit to find the what? To find y. Yes. So if I move the dx to the other side, I end up with dy equals k 1 over x squared dx. I take integral of all of that, of both sides. Integral of dy is going to be y. Integral of k 1 over x squared dx is k integral of x minus 2 dx. And that is negative k x to the minus 1 plus c. Okay? What now? I know that when y equals 2, x is 1. So I plug that in. And I find k minus k plus c is equal to 2. Yeah? I still have two unknowns, k and c. And then I've got this other point where y is negative 10, x is 1 over 4. Yeah? And I plug them in here, and I end up with another equation. Minus 4k plus c equals negative 10. What does this accolade mean? That I solve as simultaneous. So I solve this as simultaneous, and I get k equals 4, c equals 6. Okay? Now that I've got an expression, yeah, for y, and I've got values for k and c, y is negative 4 over x plus 6. And that's worth an R. Okay? Let's see. Find an explicit expression for y in terms of x if. So again, I've got a differential equation. What do I need to do here, guys? Huh? I need to isolate y's with y's, x's with x's, yes? And I've got, so I move this x plus 2. If I want to move it to the other side, it goes underneath, yeah? Because here it's multiplied. I move it to the other side, it becomes divided. The y minus 3 also, it's multiplied here, move it to the other side, it becomes divided, yeah? So I've got dy by y minus 3, and on this side I've got the x's, 2x squared plus 4x plus 1 over x plus 2. That's dy, that's dx, okay? Wonderful. Now, this guy here, to write it in a more usual form, I can write it as 1 over y minus 3 dy. And this one, what did I do with this? What do you think I did with this? Long division. Remember long division? Yeah? So x plus 2 goes into 2x squared plus 4x, 2x times, yes? So 2x times x is 2x squared. 2x times 2 is 4x. So, and then I've got a remainder of 1. Yeah? Which is this guy here. Beautiful. Now I integrate the left-hand side and I've got natural log of absolute value of y minus 3. Integrate this side as well. This one is 2 times 1 over 2 x to the power of 2. 2 times 1 over 2 becomes 1, and I end up with x squared. If I differentiate x squared, I get 2x. Yes, so I'm good here. 1 over x plus 2. All right, 1 is the derivative of x plus 2. If I differentiate x plus 2, what will I get? 1 plus 0, which is 1. So I can consider this as derivative over, so f dash over f, yeah, the integration of that is natural log of x plus 1. Do I have anything else? No, because x is to the power of 1 plus c. Cool. And now I rearrange them a little bit. Why do I have this fraction here? So when I move natural log of y minus 3 minus natural log of x plus 2, the base is the same. Difference of two logs means log of quotients. All right, so difference of this log minus this log is going to be log of this divided by this. All right, so I got that, and what am I left with? X squared plus c. And now when x equals 0, y equals 7. Yeah, so I've got a point with these coordinates. I substitute and find natural log of 4 over 2 equals c. Natural log of 2 is equal to c, therefore c is natural log of 2. And now natural log of y minus 3 over x plus 2 equals blah blah. I can leave that as it is, but I'm actually being asked to find what? To find the y. Cool. So now I look at this guy here. Again, natural log of y minus 3 over x plus 2 minus natural log of 2 is going to be natural log of that divided by 2. Okay, so I put them all in this expression here. Is equal to x squared. And now I transform the logarithmic. This is all level 2 algebra, guys. The logarithmic expression, I transform it into an exponential. What's the base of the natural log? E. All right, so I've got e to the power of x squared is equal to the subject of the log, yeah, which is this guy here. Only just a little bit rearrangement required, yes. So this divided by this equals this, therefore y minus 3 is equal to e to the power of x squared times 2 times x plus 2, yeah, and then move the 3 to the other side, and I've got y, and that's worth a t. As you can see, it's mostly level 2 algebra. The big thing about all this was what? The big thing was this first line, all right? Separating the variables, getting the y's on one side, the x's to the other side. That was the whole thing. After that, integrating this is not an issue. Integrating this, or integrating 2x squared plus 4x plus 1 by x plus 2, can I do that? Yes or no? Whenever the numerator is a higher degree than the denominator, I divide them. Yes, I use long division. If I have the denominator has a higher degree than the numerator, then I think of f dash over f. Yes, cool. Now that I got that, integrating this is easy. Writing down this equation is not, yeah, rearranging and having the variables separated. That's the big deal. Everything else from here on is, so either x or y, yeah, you get an u. Both, you integrate both, you get an r. So there is progress along the way. You always get something for something you do. And if you solve it and find the final equation for y, that's a t. Cool. Oh, this is one of my favorites. It's just requires you what? To do what? Pay attention to what you're reading. All right? Cool. A rectangular swimming pool is 30 meters long and 12 meters wide. The table below shows the depth h of x of the water at 5 meter intervals from one end of the pool to the other along the length. Use the trapezium rule. Yeah. So what is the h? Remember the h in the on the green sheets? H is 5. Yes. So 5 over 2, and then you've got these guys. Yeah. 2, the first one. So y0, y1, 2, 0, 1, 2, 3, 4, 5, 6. So y0 and y6, add them together, plus twice each of these other ones. It's on the green sheet. Okay. Plug them into your calculators. Make sure that you put the brackets wherever necessary. Remember that this is, so this whole thing inside the brackets, the middle terms, yes, 2.73, 3.3, 3.6, and 4, yes, they are taken twice. So you need to put them in brackets before you multiply them by 2. Then add the extremes, and then everything times by h over 2. Yeah? H is the interval at which you take the measurements. All right. All right, so now find the area bounded by, and that's not a minus here. I've circled it because that was a mistake in typing. Yeah, so it's x squared plus 4x. Yeah, so that it matches the picture here. Yeah, if it were negative x squared plus 4x, that would have been, if it's negative x squared, it would have been legs down. Yeah, between negative x equals negative 4 and x equals 1. All right, so for that, what do I need to do? I don't necessarily, does it say anything else here? Use calculus, integrate, blah, blah. No, I simply need to write here a1 and a2. And I've got a1 is integral of x squared plus 4x between negative 4 and 0. And the other one is between 0 and 1 of that same thing. Plug that into your calculators. Yes, like we go into graph mode, x squared plus 4x, x squared plus 4x. Oh man, it's so hard to talk with the mask. Throw that, shift G solve, and I want to integrate, yes, between 0 and no, 0 and 1, let's say. Yeah, 0 and 1. That's that bit there. And that is 2.2 and 1/3. Yeah. And now I draw that again and do Shift G solve. Again, I want to integrate between -4, that's the lower bound, and 0. Yes. And that's -10 and 2/3. All right. It's negative because it's below the x-axis, but I want to find the area, which is a surface. It's got a positive value. Yeah. So I've got 10 and 2/3, and this one was 2 and 1/3. So altogether is 13 units. Yeah. Did I need to integrate or do anything like that? No, just plug it into my stupid calculator. What was that worth? Oh, I don't have grades for this, but it's probably both of them are worth a U because they are question 1 and question 2. You don't have to show any working. Now, that being said, is it a problem to integrate x squared or 4x? No, but it saves you time. All right. So the rate at which work is done is power. Power is usually measured in watts, and 1 watt is equivalent to 1 joule per second. So that work done between t equals A and t equals B seconds is given by, yeah? So work is equal integral from A to B of P of t dt, yeah? If the equation for power, P of t, is this here, all right, where I've got the square root and the quadratic. Find the work done in the first 16 seconds. So what do I need to do? I need to take integral of that expression between 0 and 16. All right? Again, this is easy, man. Yes? Does it ask you to show anything? Yes or no? No. So what am I supposed to do here? Let's see how it looks first. You first need to graph it. So delete that and enter 45 square root of x, yes, plus 1 over 30 x squared. Execute. Let's see how it looks. Shift zoom auto. Okay, that's how it looks here. And it's all above 0. So do I need to split it up into other things? No, I don't. So I simply say Shift G solve, go to integration between 0 and 16. 0 is the lower bound, 16 is the upper bound. Ta-da-da. Why is argument equal 0? Why doesn't it want to work for me? Why do you think? Shift G solve. I want to find, so I'm going x to, when x is 16, I want to find the y calculate x equals 16. Exit. Exit. It doesn't want to do it for me, yeah? So x is, let's do window, view window, and x max is, let's say 15. No, not 15, 20. Yeah. So let's see if we can see it now, because this one goes shift view window. Let's make the y max. It says 114 and it still doesn't show us anything. So what do you think I should enter here to be sure that it shows me the whole thing? Make it 1,000. All right. And let's see. Yeah. And now shift G solve. I want to do the integral. Yes. From lower is 0 and the upper is 16. Yes. Ta-da! 1965.5. Yeah. Cool. So you understand how you deal with this. Yeah. When you cannot see it, when it's the solution you're looking for is not inside the screen, the calculator is not that clever, or is not clever enough to work out, extrapolate a solution that's not inside the visible screen. So for that reason, you need to make your viewing window zoom out and make the solutions you're looking for visible on your screen. Are we clear? Beautiful. All right. Find. Yes, integrate this guy here. Now, what do I use? Yes. So 1 minus cot of x. Yes. What is 1 minus cot of x? Look on the green sheets. Have you got the green sheets handy? Where it says integration differentiation. 1 minus cot of x. Huh? Couldn't find it? No? No? What is it? Cosec squared of x, yes? Cool. So I know that there is a relationship between the exponent here and this guy here in the front. All right. So I mark this, I substitute this whole e to the power of, because it's e to the power of a function, yeah? And I know that when I differentiate, e to the power of a function is e to the power of that function times the derivative of that function, yeah? So I marked it as u, e to the power of 1 minus cot of x dx. I substitute that for u, and then I differentiate that. So I've got du by dx is e to the power of, so e to the power of a function stays e to the power of a function, yeah? Times 1 minus cot of x differentiated. How much is 1 minus cot of x differentiated? Of the green sheets? Cos x squared of x. Yes? Ta-da! And what do I have now? Let's have a look. I've got exactly this guy here. Yeah? So, and now, if I move this dx to the other side, that means I've got du is equal to da-da-da-da-da dx. Yes? So du is equal to e to the power of 1 minus cot of x times cos x squared of x times dx. Yeah? Wonderful. So now u is going to be integral of that, yeah, from between pi over 4 and pi over 2 of this e to the power of 1 minus cot of x times cosec is 1 over sine squared, and that is that. You just enter it into your calculator, and that is also e minus 1. So why did I cut it short here? So from here I cut it short here. Huh? It doesn't ask me for any integration or anything. What am I instead being asked to work out? What is cot? Hmm? Sure. What is cot? It's something that I don't have on my calculator. What is cosec? Also something which I don't have on my calculator. How do I write cosec on my calculator? Anyone? 1 over sine. So if I have cosec squared, let's get rid of all that. Shift view window and make that initial and exit. So how do I write cosec squared? I open brackets and I say 1 over sine of x and all that to the power of 2. That's sine squared. Okay? How do I write? So that's cosec negative 1 minus cot of x. How do I do that? Cot of x. 1 minus cot of x. Let's write all this thing, yeah? So I've got cosec squared times e to the power of, so I've got e to the power of 1 minus cot. So 1 minus cot is 1 over 10, yeah? 1 over 10 of x. Yes. And close that bracket there. Execute. Let's draw it. All right. And I want it between pi over 4 and pi over 2. And now I go Shift G solve. integral between pi over 4, so pi over 4, that's the lower, and pi over 2, that's the upper. Okay, it doesn't want to do it for me. So shift G solve. Again, integral between pi over 4, shift pi over 4, execute that's there, and pi over 2, shift pi over 2. Something is wrong here. So I've got 1 over sine of x squared times e to the power of, all right, so that 1, 2 pi over 4 would be shift view window, and now let's exit that, and I've got 1, 2, 3, 4, 5, 6. Pi over 4 is 0.7 something. So between this and pi over 2 is 1 point something here. Let's try again. Shift G solve. Integral between shift pi over 4. Yes, that one there. And shift G solve. All right. Again, pi over 4. Execute. And 1 point. Shift pi over 2. Why it says error here? Okay, so that's pi over 2 here. Yeah, and that here is pi over 4. Why doesn't it work? Does it work on your calculators? Hmm? And pi over 4. Shift pi over 4. All right, so it's this area here. Yeah? between pi over 4 and pi over 2. And now if I want to do shift gsolve integral of the first one, execute, and again pi over 4, pi over 4, and pi over 2. It says error again. It doesn't know how to do it. Can it do it on your calculators? It might just be my... No? I don't get it. Why? Does it look the same? Yeah. This thing. So it's this area in here. And that should be 1.7183, which is actually 1 less than E. But I don't understand why it's not working on the calculator. Because it has very clear limits. Yes, that's pi over 4, that's pi over 2. That is the function. It's above 0.
How are you solving it?
Hmm?
How are you trying to p-solve?
So I want to find the area, yeah, between, yeah.
If you go shift p-solve,
Shift gsolve,
then you go over to
integral,
yeah.
yeah.
Then you type, so you go to the number pad, you put
Yeah. Instead of pi over 4, how much is pi over 4?
No, you can put in pi over 4.
Yeah, I've tried that, but it didn't work. Let's see if that was the reason. So pi over 4 is the shift pi over 4, 0.785, 0.785, and upper is pi over 2, pi over 2, 1.57, 1.57, execute. All right, so it worked. It doesn't take the pi. All right, so if you enter the values, those values as numbers, it's probably too much for the calculator to work out the value of pi. Yeah, but if you enter those values to 3 decimals and you enter them, you see how you've got your thing there. Yeah. So shift gsolve bam 0.785. That's the lower, and the upper is 1.57. Yes, and that is 1.7169. All right, I got here 1.7183. Okay, but you need to work those numbers. That's why I didn't bother carrying on with the substitution here and trying to integrate nicely, because it says find this. Okay, you just enter the expression, making sure that you've got, instead of cosec squared, you've got 1 over sine to the power of 2. Yes? Don't forget the brackets. And see, just for working that on your graphics calculator, you get an R. There's no integration required. A dog's acceleration in meters is given by, and you've got an expression where m is the distance in meters. Yes? From a stick, and t is the time in seconds. Initially, the dog's velocity is 4 meters per. When you hear initially, that means what? At t equals 0, yeah? Don't worry, don't bother about, I'm taping this, and I'll post it, okay? Initially, the dog's velocity is this, and it is 2 meters from the stick. So S0, displacement 0, is 2 meters, yeah, when t equals 0. So A is the derivative of the rate of change of velocity over time. Therefore, I rearrange that, and I've got dv equals a dt. Yeah, I've got an expression for acceleration as a function of time. I plug it in here by dt, and then when I take integral on both sides, I'll have v equals integral of a dt. Yeah, that is to the power of -2. That means I put it underneath, yeah? Or I keep it as it is, and that's how I differentiate it. Kt plus 1 is what? Kt plus 1, differentiated. Huh? K, yeah? So when I differentiate that, that's why I need to divide by k here, yeah? Or times by 1 over k. Because when I differentiate that, I'll get a k in front. All right? Cool. Plus c. And now when t equals 0, v equals 4. And I find the constant of integration. Yeah? And the constant of integration is -1 over k plus c. Yeah? And c is 4 plus 1 over k. Yeah? And now I know that velocity is ds by dt. I do the same thing. I integrate both sides. I integrate the v, yeah? And I'll end up with another constant of integration, yeah? Which is this one here at t0. So see how these are all these terms are 0. When s is 2, t is 0, yeah? Natural log of 1 is natural log of 1. Log of 1, or any base log of 1, is e to the power of what is 1? 3 to the power of what is 1? 3 to the power of 0, yeah? So this one, yeah, is going to be 0. It's going to be, yes. You've got these everywhere, which means 0. Therefore, C2 is going to be 2. You plug it in there, and you've got, that's your expression for displacement. And that, if I'm not mistaken, is also worth a t. All right?